Hello, how you doing? It's Mr. Do the Math, and today we're going to talk about function notation. Let me double check. Function notation. There are two examples that we're going to discuss and kind of juxtapose together, right? Those two examples are equation notation and function notation. Equation notation looks like this: y equals mx plus b, right? Y equals mx plus b. These two are both slope-intercept equations, right? So equation notation is y equals. Function notation is f of x. That's the way you read that. Fx equals mx plus b. Those go on those two lines, right? Again, this reads f of x. That's how you read the letter in the x in parentheses, all right? F of x, okay? In function notation, f of x, that goes on the line, g of x, h of x, all mean y, right? They're the same as y, right? They're another word for y. F of x, g of x, and h of x, right? All right. The parentheses in the notation does not mean f times x though, right? So that's what goes there, right? So f of x does not mean f times x, right? That's not what that means. And that goes in that last line. All right, again, f of x, g of x, and h of x all mean y. So whenever you see anything like this, you're trying to find a y value or an output value, all right? Actually, I take those out because I can keep them off. Like, now you just drew more attention to your heads again. All right. The evaluating process, right? Let's look at the evaluating process. All right, evaluating functions. Remember, when we evaluate functions, we're substituting in a value. We're substituting, right? So, in the evaluating section, evaluating functions, right? Evaluating, what I need you to do is highlight or underline the word substitute, right? When you're evaluating functions, that's the process of substituting in a value for x. So you sub in x to find y. Substitute x to find y. Substitute the independent variable in to find the dependent variable, right? That's what we've been doing like for the last couple of weeks, right? Y'all here, tune in, right? Substitute x to find y, okay? So whenever you see the word evaluate, that means substitute, right? Whenever you see evaluate, that means you're gonna have to substitute somewhere, okay? And so we're gonna practice. All right, number one, you have f of x equals 4x plus 1, where x equals 2, okay? F of x equals 4x plus 1 and where x equals 2. Okay? What that means is, wherever you see an x, you're going to put a 2 there. So we can write it down like this is what I want you to do. Put f of 2 equals 4 times 2 plus 1. Okay? So again, what we did, Evan, is we put 2 in the place of x. Right? We put 2 in the place of x. Evaluate means to substitute and then simplify. Right, so we substituted it in, now we're going to simplify it. So f of 2 is going to equal 4 times 2, which is 8 plus 1. Right? 8 plus 1 equals what?
9.
Right, so f of 2 equals 9. Okay? What that means is when x is 2, y is 9. God bless you. So you have an ordered pair here. 2, 9 is your ordered pair. Right? 2 being x, and 9 being y or f of x, right? They mean the same thing. Everybody good so far? All right, let's look at number 2. Number 2, read it to me, please.
G of x
Good.
equals negative 5 over 2 x plus 3 4 x equals 6.
X equals 6. Very good. Great reading. G of x equals negative 5 over 2x plus 3 when x equals 6. So G of 6 equals, so first thing you want to do is substitute. G of 6 equals negative 5 over 2 times 6 plus 3, right? We substitute it in, right? Then we do the math, right? So we can do it two ways. 5 times 6 divided by 2, or 6 divided by 2 times 5, right? 5 times 6 divided by 2 is negative 3. Negative 30 over 2. Sorry, negative 30 over 2 plus 3, right? Negative 30 over 2 is what? Negative 15 plus 3. Negative 15 plus 3?
12.
Negative 12.
Negative 12, right? So g of 6 equals negative 12. So when x equals 6, y equals negative 12. That's your ordered pair. Okay? Does everybody understand? Everybody see how we got 30 over 2? Yeah? You multiply the two numbers together, and then you bring the denominator, right? Let's think of number 3. Somebody read number 3 for me, please.
H of x
Very good. H of x
equals negative 2x plus 5.
Negative 2x plus 5.
X equals negative 1.
X equals negative 1. Okay? First things first, evaluate, substitute. Everywhere you see an x, you put negative 1 there. So it'll be negative 2 times negative 1 plus 5. Okay? Then you do the math. Alright? Negative 2 times negative 1 is what?
2.
Positive 2 más 5 plus 5?
7.
7. Right? So h of negative 1 equals 7. Do the last one. You gotta start working on the last one. Alright? So then, for here, x equals negative 1, 7. Alright? Alright, let's work on number 4 right fast. Number 4. Oh, look, let's do number 4. Read number 4. Go ahead.
Fx equals x plus 2 or x equals negative 6.
X equals negative 6. Okay? Very good. F of x equals x plus 2. Alright, so we substitute x in, right? 6 for x. And then it'll be negative 6 plus 2. Different sign, subtract. Keep the sign of the bigger number, then you'll be exact. So you got f of negative 6 equals negative 4. How many students had that? Good. So your ordered pair was negative 6, negative 4. Okay? So, the main thing is when you evaluate, you substitute, right? So getting you to see finding the output value when giving that input value. Okay? Alright, now let's talk about graphing. Alright? So, how to graph a linear function. So next to that, put making a table, right? Making a table, right? How to graph a linear function, making a table, right? Let's make a table, right? We're gonna make a table. That's the way we're gonna do it first, okay? All right, let's see. So this is graphing using a table. A table. How to graph making a table. Right? Step 1, making a table. How to graph a linear function making a table. Alright, so the first thing you want to do is you want to evaluate using 3 different points. So right? Evaluate using 3 different points. Right? Evaluate using 3 different points. And so typically when you have the number connected to the x being a whole number, you can use any points that you want. Like you can use any points that you want. But when you have a fraction connected to the x, you want to use multiples of the denominator. And I'll say that again in a second. So first thing you want to do is you want to evaluate, get your 3 points, right? Using 3 x values, right? 3 different x values, right? So not 3 points, 3 x values. 3 input values, right? Then you're gonna plot. When you put in 3 input values, you get 3 output values. So then you'll have 3 points. So you plot the 3 points that you found from step 1 from our table, right? Then 3, you'll make a graph, right? By connecting the dots. So you'll connect the 3 coordinates and make a straight line. Connect the dots, connect the points, okay? Connect the points. Making a straight line. Straight line goes on that line, okay? So, what's this, number 5? Number 5, you have, say f of x equals 3x minus 4. F of x equals 3x minus 4, okay? So, the number connected to the x is a whole number, right? It's just 3. Or it could be seen as 3 over 1, right? Therefore, when we make our table, we can use any points that we want. And for simplicity's sake, I would advise you do something like use 1, 0, and -1, right? Let's do it in numerical order. So -1, 0, 1, right? So use those points. Use those x values, all right? Let's stay around the origin, because if we can stay around the origin, we can it's highly likely that we'll have values that will fall in that 10 by 10 coordinate plane, okay? So now, we have our 3 values. From there, we evaluate. So we're gonna substitute -1 in for x. So it'll be 3, I'll put it here first. 3 times -1 minus 4, right? That's gonna give us our y value. So it'll be 3 times -1 minus 4. 3 times -1 is what? -3. -3 minus 4?
-7.
-7. Same sign, add and keep. So when x is -1, y is -7. All right? The next one is 3 times 0 minus 4. 3 times 0 is what?
0.
Minus 4?
-4.
-4. So it's 0, -4. Then the last one is 3 times 1 minus 4. 3 times 1 is what?
4.
3. 3 minus 4?
7.
-1. Right. So now we've evaluated using our 3 points. Now we're going to find our 3 points. So our 3 points are -1, -7, 0, -4, and 1, -1. All right. Those are 3 points. All right. Now we can plot these. Plot these and connect the dots. All right. So you plot these points and connect the dots. Okay. Yeah. Plot the points. Plot those points.
Okay.
So, -1. Four. And 1. All right. So we got our points looking something like this. And then you use a straight edge to connect the dots. Okay? Use your ID to connect the dots. Okay? Let's look at our last example. Number 6. Number 6. Read number 6 to me, please.
G of x equals -3 over 2 x plus 5.
All right. So, in this particular example, you have a fraction connected to the x. 3 over 2 is connected to the x. All right. So, when we find our values, when we have a fraction here, you want to use multiples of the denominator. Does everybody know what a denominator is? Yes? What's the denominator? 2 is the denominator, the bottom number of a fraction. So for your input values, use multiples of the denominator. So you use multiples of 2 so that you'll get whole number output values, right? So in our table, if we use multiples of 2, what will we use? What's the multiples of 2? Yeah, Evan. Yeah, -2. Yeah, you can use -2, 2, and 4. Good. -2, 2, and 4, right? You can use -2, 0, and 2, right? But good. Always use multiples of the denominator, okay? So then we can do the math, all right? Let's do the math. So we're gonna have -3 over 2 times -2 plus 5, right? So let's do it. -3 over 2 times 2 plus 5. So again, we multiply. 3 times 2 is what? So it'll be -6 over 2 plus 5. -6 over 2 is -3. Then you add 5, you get what? -3 plus 5.
Oh, 2.
Thank you. So that's 2. All right, it's x, it's y. All right, then we got -3 over 2 times 2. Oh, that was -2. My bad, -2. That makes this positive. That's gonna be +6. It's +3. I'm sorry. We should have substituted in -2. So that'd have been -3 times -2, which is +6, which will make that 8. This first point is 8. The second point is gonna be 2. All right, the second point is going to be the -3 over 2 times 2 plus 5, which is your -6 over 2 plus 5, right? Which gives you a 2, because that's -3 plus 5, okay? And then the last point is 4. So it'll be -3 over 2 times 4 plus 5. Right? 3 times 4 is -12 over 2. -12 over 2 is -6 plus 5 is -1. Right? So your points are -2, 8, 2, 2, and 4, -1. Okay? So we'll plot those. 2, 2, right? 4, 4, -1, 5, and then you have -2, 5, 8. 1, 2, 3, 2, 3, 4, 5, 6, 7, 8. So 2, 8. Okay? So your line will be going in this direction. Okay? And what'll happen is you'll end up with that 0, 5. So if we put a 0 in between here, we had 0, 5. So 1, 2, 3, 4, 5. So there's your line. Everybody good with that? Elijah, what's up? Are you good? Everybody good? Okay, so today what we did was we evaluated functions using functional notation, and then we graphed making a table, right? That's what we did so far. And so after that, we're going to practice some more. So if you have any more questions about this, comment below. If you haven't already, don't forget to like and subscribe. Until next time, this is
Hit
Little
the
Math
follow button.
out.
Stop